Okay, 2.3, linear functions. So we're going to talk about slope of linear functions, slope-intercept form of a line, point slope, general or standard form, graph a linear equation, talk about horizontal vertical lines, model data with linear functions, and just model to make predictions. So the linear equation, we've been talking about it. Here, this is ax plus by equals c. This is when what we call standard or general form. Standard form. We are also used to looking at it, and this is what you'll soon know, what we call slope-intercept form. But so far in the class, we've been looking at linear equations like mx plus b, but equal to 0. Right now in chapter 2, we're finally adding in that second variable y. And then slope, remember that it's the ratio of the vertical change in horizontal, and then vertical change and horizontal change. So slope, right, m, right here, rise over run. I don't need that then, yeah. So it's rise over run, little formula there for you. Here's a funny little anecdote to help you remember if you struggle, whether it's y over x or x over y. So hopefully you are familiar with duck, duck, goose. So duck, duck, goose, think about it. You're all in a circle. One person standing up, patting the little children's head like duck, duck, goose. And then think, what does the goose do? If you're the goose, what do? You rise up and then you run. Oh, right? Because what you do is you try to like get to your seat before the gooser, if you would. So rise over run, right? You don't like scooch along on your bottom and then try to get up and get after someone. Nope. Think duck, duck, goose. First you rise and then you run. So it's slope, rise over run. So here's an equation, y2 minus y1 over x2 minus x1. Might want to star highlight whatever you need, make a note that it might be note card worthy for test 2 or whatever test it is. So we'll just do one example for sake of time. So just using the formula. So this would be 4 minus -2 over -1. Oh, excuse me, my brain's going crazy. This is 0.1, here's 0.2, there we go. Hello. So m is what we use to represent slope. So y2 is 4 minus -1. There we go, now we're in business. My brain was like, Leslie, something's not working, and it was right. So -2 minus -3, so 4 plus 1 over -2 plus 3 is 5 over 1. So here we have a slope of 5. And then I want you to stop and practice B. And for B, you should get that the answer is -6/5. So that's how you know you got it right. Special slopes. Well, horizontal lines, right? That's y equals some number. They have a special slope of 0, right? If I have just a horizontal line, it's a slope of 0. If I have a vertical line, aka x equals some number, this has a slope of undefined. Undefined. Sorry, my brain was like, is undefined right? Who knows? Y'all can chuckle. My brain's not wanting to work right now. So these are our special slopes. So horizontal lines, right? They have a slope of 0 or flat line. Vertical lines, they have a slope of undefined. So point slope form of a line, we have, if we have a point x comma y and a slope m, then it's exactly what it sounds like. Oh, let's say we have a point x1, y1. It's y minus y1 equals m times x minus x1. point slope form. Oh my gosh, you can't see that. Oh my gosh, I'm so crazy. So here's your point, here's your slope, here's your equation. Also star, highlight, make a note, whatever you got to do, may be note card worthy for your test. So remember the old people back in the day called it like they saw it. Here's a point, here's a slope, and then you just plug and chug. So let's try it. So write an equation in point slope form of a line with slope 4, okay, and passes through the point -1, 3. Then solve the equation for y. All right, no problem. Well, remember we have y minus y1 equals m times x minus x1. So this is y minus 3 equals 4 times x, really plus 1 because of that double negative. So now if I'm solving for y, let's distribute that 4. 4x plus 4, subtract over, or excuse me, add over the 3, really. So 4 plus 3 is 7. So here we have what we know as point slope form, and then we have translated into what we will know is called slope intercept form. Intercept form, because here's your slope, and kind of spoiler alert here, this is your intercept. So I want y'all to try 3. The solution is y equals -3/2 x plus 3. Okay, so that's how you'll know if you got it right. So practice with that one. So then slope intercept form of a line, it is like what I just gave you. So it is y equals mx plus b. Remember the old people back in the day called it like they saw it. M is equal to slope, hence the name slope intercept. B is equal to the y-intercept. Again, call it like they saw it. So if I want to graph the line, f of x equals -3/2 plus 2, we slap down some axes. We have our jumping off point. Let's go purple, actually. We have our jumping off point of the y-intercept of 2. And then slope, remember this says that we go down 3, 1, 2, 3, and then right 2 to represent a -3, 2, or -3/2 slope. So down 3, right 2. You only need 2 points to graph a linear line, and bingo bango, there you go. So 5 to graph y equals 4, 6 to graph y equals 2. Well, what kind of line is 5? Horizontal. In my head, that's how you said it. So if I just mark that as -4, well, this just says my y is always -4. No matter what x is, y is always what number? -4. Similar idea for x equaling 2. We just slap down 2 and then graph. What we think of this as meaning is x is always 2, no matter what y is. While we're at it, what's the slope of this line for example 5? Y'all remember? 0. What's the slope of example 6? Vertical line? Undefined. Undefined. So the general standard form of a line is what we have at the beginning here. Ax plus by equals c, where a, b, and c are real numbers. A and b can both not be 0, because if they are 0, then we just have a constant, right? Just have a constant. And also generally, A, B, and C are integers. Basically no fractions. Are integers, no fractions. So if you have fractions, you'll want to multiply through by a common denominator. So let's use this. All right, let's put it to work. Example 7, find the slope and y-intercept of a line whose equation is 3x plus 2y minus 4. Well, the easiest way to do this is put it into what form? Slope-intercept form, right? They called it like they saw it. So all this means is that we want to solve 7 for y. Simple as that. So I'm going to subtract over the 3x and add over that 4. So 2y equals negative 3x plus 4. And then I'm going to divide by 2. So y equals negative 3x plus 4 over 2. You can leave it like this, or you can split the denominator and say that this is negative 3 halves x plus 2. There you go. So actually here, so now you tell me, what's the slope? Negative 3 halves. And what's the y-intercept? Whoop, 0, 2. I like to think you got that, so good job. So example 8, if we want to graph it, again, the easiest way to do it is to put it into the slope-intercept form. So what do we want to solve this equation for? Y. Actually, I'm going to add the 3y over. So it's 4x minus 6 equals 3y. And then divide by 3. So I have 4/3 x minus 2. So now when we're graphing, right, you have a jumping off point of the y-intercept of negative 2. So now we have a slope with a positive 4/3. So up 4, 1, 2, 3, 4, and right 3. We only need 2 points to have a line, a linear line. Ooh, look, see, that is not my best line. That is squiggly. But there you go. That's how you can graph it. So an application here, let's see. The amount of carbon dioxide in the atmosphere, measured in parts per million, has been increasing as a result of burning oil and coal. The buildup of gases and particles traps heat and raises the planet's temperature. The bar graph below gives the average atmospheric concentration of carbon dioxide and the average, I lost my place. Yeah, the average global temperature for 6 selected years. The data are displayed as a set of 6 points in the rectangular coordinate system in the other graph. So A, show on the scatter plot is a line or near the 6 point. That's also known as a line of best fit. Write the slope-intercept form of this equation using this notation. So here, let me zoom in a little bit. It's probably pretty hard to see, but the 2 points that are noted right here are 326, 57.06, and then 385, 57.99. So we're going to use these 2 points, and our procedure is 1, find slope, okay, and then 2, use point slope to create equation. All right, so that's kind of the game plan there. So slope, remember y2 minus y1. So 57.99 minus 57.06 over x2 minus x1. So 385 minus 326. I'm just going to pop this into my calculator. Let's see. 57.99 minus 57.06 divided by 385 minus 326 is approximately 0. Let's see. Let's go squiggle. Approximately 0.01576. When it doesn't tell me where to round, I just like to round pretty far out. All right, so here's my slope. Here's my slope right there. Let me zoom back out. There's my slope. So now we just need a point. Doesn't matter which one, not at all. Let's use the first one. So now y minus 57.06 equals our slope of 0.01576 times x minus x1, which is 326. Now we're just going to distribute, and then add the 57 over. Oh, sorry, I don't need this parenthesis. Went a little crazy there. So I have y minus 57.06 equals 0.01576x minus, let's see, this number times 326 is about 5.13, let's say 9. Then I'm going to add the 57 over here, 57.06 minus 5.139 is 51.92. So y equals 0.01576x plus 51.92. And there we go. So here is what we would call a line of best fit. Now it's not a perfect line, but it just best fits the information. So the pre-industrial concentration of the atmospheric carbon dioxide was 280 parts per million. The United Nations Intergovernmental Panel of Climate Change predicts global temperatures will rise between 2 degrees and 5 degrees if carbon dioxide concentration doubles from this pre-industrial level. Compared to the average global temperature of 57.99 in 2009, how well does this function from part A model this prediction? Well, so essentially what we're going to do is we are going to see what the equation is going to give us. So if we have 280 to begin with, if it's thinking it's going to double, well then 2 times 280 is 560, right? 280 times 2, checking my math in the calculator, yeah. So this is double. So what we want to do is actually pop in the 560 into the equation, right? Because it says they're predicting the concentration doubles, it'll rise between 2 and 5 degrees. So if y equals 0.01576 times 560 plus 51.92, I'm just going to pop this into my handy dandy. So 0.01576 times 560, enter, plus 51.92 is 60 let's say 75. So y equals 60.75. So now we compare this to the 57.99. So 60 minus the comparison degree they gave us of 57.99 is 2.75. So it's a difference of 2.76. So if they predicted a global climate change raise between 2 degrees and 5 degrees, then this checks that off, right? Because this is between 2 and 5. So our equation is within the predictions. Pretty cool, right? And there you have it. There's 2.3. Awesome.